Now problem number 29 of exercise 7.3. Now problem number 29 of exercise 7.3. Integration of 0 to 1 dx divided by e power x plus e power minus x. So this is definite integral solution, definite integral problem. So after integrating, we'll substitute the limits. That is upper limit minus lower limit we can do. Now let us see how can we solve this problem. First we can rearrange the problem as integration of 0 to 1 dx divided by e power x plus 1 divided by e power x. E power minus x can be written as 1 divided by e power x, which is equals to integration of 0 to 1. By taking LCM all, this will come to the numerator e power x dx divided by e to the power of 2x plus 1. So now let us go for substitution. So our substitution is here. Let e power x as t. Then we get e power x dx as dt. So in terms of t, integration of, we will not substitute the limits now. Again we go back for function in terms of x, then we substitute the limits. So e power x dx is only dt. dt divided by e power 2x is e power x whole square, which is t square plus 1. So this is nothing but integration of dx by x square plus 1 is tan inverse of x, here tan inverse of t. There is no need to write c because we are going to evaluate definite integrals. Now replace now this one t as e power x. So integration of, we have done the integral now. So we are writing the answer. So the answer is tan inverse of t, or tan inverse of t should be replaced by e power x. Now write the limits. The limits is for x 0 to 1. If you are substituting here means you have to change the limit also. Like suppose if you want to change the limit, we can do like when we are substituting e power x is equal to t at this step only, when upper limit, when as x turns, that is it, when x is equal to 0, t is equals to e power 0 1. When x is equals to 1 and t will be e power 1. So we can, if you are changing like this, then in this step itself we can go like tan inverse of t is there. The limits are, the lower limit is 1 and upper limit is e. So tan inverse of 1 minus tan inverse of e. This is the tan inverse of 1 is pi by 4. So pi by 4 minus tan inverse of e. This is one way of giving answer. Or if we are going back with x, now we can substitute here limit tan inverse of e power 1. So tan inverse of e power 1 minus tan inverse of e power 0, which is 1. So the answer is again tan inverse of e minus 1. Minus tan inverse of 1 is nothing but pi by 4. Okay. Symbols are changing here. Upper limit is, yeah. Here I have done mistake with first I have to do upper limit. So it is upper limit minus lower limit. So here it is first e should be done. Then tan inverse of 1. So here also you will get the answer as not this part. It is first is tan inverse of e, then tan inverse of 1. So we will get this answer as, okay. So tan inverse of, this is tan inverse of e is the first term. That is upper limit has to be applied first. So tan inverse of e minus tan inverse of 1 is pi by 4. So either this way we can solve or like this way. Anyway, it's correct.